which one of these here do you think has a correlation of positive 1? Top row or bottom row? And then the
Top row.
top row? Okay, so the top row?
Top row, the third one.
Yep, the last one. Exactly, because it's a perfect line with a positive slope. As x goes up, y goes up. They both go up together. Okay, so which one would have a correlation of -1? Anybody take a second? Everyone's private chat me. So top or bottom, and the first, the last, or the middle right, middle left, or the middle. Yep, bottom third one. Good, perfect. Great. You can see that's totally perfect line with a negative slope. As x goes up, y goes down. It drops. Good. Excellent. All right, and then the other easy one is which one has a correlation of 0? Correlation of 0? Yeah, the last one, the last graph on the bottom, the black one, exactly. This one has a correlation of 0. And then we can kind of look at these two. You know these two are both positive. So which one is more, so these are going to be these two right here, 0.5 and 0.8. Which one is more like a line? I think this one's more like a line, right? So it means that this one should be closer to 1. Since 1's a perfect line, so then this should be exactly, this one should be 0.8, because 0.8 is closer to 1 than 0.5 is. Because it's more like a line. And this one would then have to be 0.5. And then of these two, these are the two with negative slopes, so they're going to be negatives. Which one's more like a line? Looks like this one is. So this one should have a correlation coefficient that is closer to -1. So of these two, which one is closer to -1? -0.8. So I'm going to go ahead and, whoops, drop that down a little bit, move that down a little bit, and you guys will see. No, you won't. Try that again. All the numbers on there. Okay, good. So makes sense, everybody? Any questions? You all, everybody all right with that part? I should make it a little bit larger. Maybe move it over a little bit more. Okay. So this is the formula for the correlation coefficient. So this is how we find what R is. Right? So this is how this is. So we just a second ago we just looked at what R represents. Right? When R is when R is 1, it's a perfect line up. When R is -1, it's a perfect line down. But now we're looking at how do you find R. It's this formula here. And so you kind of look through, here's n times the sum of all the x's times the y's, minus the sum of all the x's multiplied by the sum of all the y's. And then this is divided by the square root of, in this first section is n times the sum of every x squared. So here you're going to square every x first, and then sum them. And then over here, you're going to sum the x's first, and then square them. And similarly here, n times the sum of all the, first you take all the y's and square them, and then you add them up. And then here, with parentheses, you add them up first, you add the parentheses, and then you square them. Because remember, exponent takes precedence first, so we would do this first in this case, before you add, because this comes before the addition. All right, so this is the formula that we're going to use, or that people use. This is the formula that I used when I was going through college. And then the neat thing that's really, really cool that I didn't realize at first is that this is really the same thing as this. You can also do it this way instead, where you do 1 over n minus 1, because it's a sample, right? So you're dividing by n minus 1, times the sum of this is just the z-score. You take an x value minus the mean divided by the standard deviation. So this is just a z-score for each x. So I'll find one. So like here's an x, I'd take 60, find the z-score for 60, and then find the z-score for 11. This is in the y's, right? So 11 minus the y bar over the standard deviation for the y's. And I would find this guy's z-score and his z-score and multiply them. And then I'd find 72's z-score and 69's z-score, and I'd multiply them. And I do that for every single point. And then, if you add up all of those and divide by n-1, you get the same thing as this. It's really kind of cool that it kind of works like that. We're just going to focus on this top one. So I'm going to show you guys what all these, just a review of what all these different things stand for and how to find them. Let me move this up so you can read it better. And how about, Allie, can you go ahead and read for us?
N equals the number of pairs of sample data. Sigma x equals the sum of all x values. Sigma x squared is equal to each x value squared and then added. And then sigma x in parentheses squared equals all x values added and the total is squared. Sigma xy is equal to each x value multiplied by the corresponding y value and then the sum of all such products. R is equal to the linear correlation coefficient of the sample data and then
Row?
Did you say
Row?
Yeah. Linear correlation coefficient of the population of pair data.
Perfect. And notice how she said sigma here. You can also say sum of if you want, but this is a capital sigma as opposed to the little lowercase sigma we're used to for the for standard deviations with a circle with the tail. That's the lowercase sigma. This is a capital sigma, which is summing, the sum. Good. And again, rho is for the population correlation coefficient, and R is for the sample correlation coefficient. Let's go and take a look at a problem. We'll do it together. So everyone bust out your TI-84 calculators. So you're going to use them for this. We need to do this formula, but we're going to use our calculators to make our lives really, really, really easy. So go ahead and get your calculator out. Sorry, here's what's out of the way. Okay, so everyone has their calculator out. Oh no. Share. Okay, good. Okay, good. So I'm just going to put all the x's into list 1, all the y's into list 2. So I'm going to go to stat, edit. Right, so stat's right here again. The very first option is edit, so hit enter, and just type them in. Now, if you need to clear, go up to on the L2 and hit clear enter, and it'll clear it. I'm going to go over to the L1. I'm going to go up some on the L1, hit clear enter, and then that will go away. So then I can type them in. So everybody type yours in, 63, 29, 20.8, 19.1, 13.4, 8.5. And then go over and type in your y's as well. 7, 3.9, 2.1, 2.8, 1.5. And then, this is really important. Double check all of your numbers, because if you screw up just one number, everything's going to be totally wrong. So you got to double check. Last class I missed one of the numbers here, so this ended up being like, 90 ended up being 0, which is a big difference, right? So double check them, make sure you got them all right, because if you mistype this, these two chapters, 10 and 11, are the easiest chapters of them all, period. We're going to be using the calculator for a lot of it. The thing is, if you're not here, then you won't know how I do it. And I'm doing it very superficially. It's kind of like, kind of the light version. So if you try to do it on your own with the book, then you're going to be torturing yourself a lot more, and it's going to just be a lot harder than it will be in class. So again, just make sure you don't miss these 4 lectures today and the next 3 after this. We're going to just be going over these, and again, it's not going to be very difficult. It's not hard at all. It's just you just need to know how to do it. Incidentally, that thing you did a second ago where you figured out which one with which piece, that was, let me see if I can pull it up. All right, this one here, something like this is going to be on the exam. And this is not hard at all, right? It's like the easiest 4 points of the exam, or some of the easiest 4 points of the exam. But if you don't know how to do it, it's going to be really hard. So just make sure you stay on top of that. Okay, so you have all your lists in, you double check them. We're going to do stat, calc, and we're not going to do 1-bar stats because we have 2 variables now. Before, in chapter 9, we had 2 samples, right? Sometimes we had like presidents' heights and their opponents' heights, presidents and their opponents, but they're still the same thing. They're still heights, right? Or you might have had blood pressure in your left arm and your right arm, but there's still blood pressures. Now we have 2 variables, 2 different things. We have cars and income. They are not the same thing at all. They're totally different. Cars, X's, income, Y's, 2 totally different things. Cars and income are not the same at all. So now we have 2 variable stats. So go down to 2-bar stats and hit enter. If you have a fancy calculator, then you'll put in your X's, your list 1 for the first list, and then your Y's you'll put in list 2, and then for the frequency list, just leave that blank. Blank or 1, I think. So here I'm going to put in 2-bar stats. I'm going to put L1, so second 1 gets me my L1 up here, comma, second, and then L2, I need to hit the 2 there to get the second L2. I'm going to hit enter, and that's going to give it to me. And then you'll see everything. So here we've got my x bar, which I don't need. We have the sum of the x's, which I need, and the sum of the x's squared, which I also need. I need both of these 2 things, so that's super useful. If I scroll down, see how it has this little arrow down? Means I can scroll down. There's more stuff. Oh, look, there's my y bar and my sum of my y's and sum of my y squareds. It's all in there, right? So grab those as well. If I scroll down more, oops, there's my sum of my x's times the y's. That's the other thing I need. So it gives me all this stuff that I need. It's super useful. All right, so we have all these things. That's how you get it. Again, that's stat, calc, 2-bar stats. That's going to be second 1 to get the L1 up here, comma, second 2 to get the L2, and then hit enter. Or if you have a fancy calculator, you'll put in list 1 for the first one, list 2 for the second one, and leave the frequency blank. All right, so now we have all of that, which is great. Super, super useful. Let's go to page 27, sorry, next page. And this is just me showing you guys how to do that, what I showed you. Oops. Great. So now we're going to plug them all in. So you guys go ahead and plug them all in here and find your numbers. I'll go backwards. Make you guys do it here. So again, we don't need this stuff here. You don't need to fill that out. Don't worry about filling that out. Just use these, write these totals in down here on your sheet. This is on the page 2 of chapter 10 notes at the bottom, the one we're doing together, cars and income. So just write these numbers in along the bottom and then write in your formula and then calculate it. So I'm going to give you guys a couple minutes. I'll open up the breakout rooms so you guys can go in there and confer with your neighbors. I'll give you guys just like a minute and a half, 2 minutes to do this. Plug those in and calculate them. Okay, so you guys should all be back. And these should be the numbers you should have down in here. right, for each of these. N is 6. The sum of the xy's, is 682.77. The sum of the x's is 183.8. The sum of the y's is 18.7. N times the sum of the x's squared. That's this one right here, the sum of the x's squared. And then this is the sum of the x's. So this is just, you take the sum of the x's, and then you square them. And here you take the sum of the y squared, so that's this one here. And then you take the sum of the y's, 18.7, and you square them. So you should have, this is what you should have had written down as your formula. If not, maybe rewrite it quickly in there. And then when you go through all that, don't forget to square, you square rooted it hopefully. You got R is 0.982, which we're going to be using later on today. So you'll need to have that number in there. R is 0.982 for these auto car rental companies. Okay, so everybody all good with this so far? The beauty of it is that you don't need to do this anymore, right? This is what I had to do in my day. Only I didn't even have the calculator to sum them all for me. I had to do that all by hand. Nowadays, you can do stat test lin-reg t-test. So let me show you. You're going to put your x's in list 1 and your y's in list 2, which you have already. So here it is. My x's are in list 1. My y's are in list 2. And then I'm going to do stat test. So stat right here in the middle, go over to test. And then I need to go up because mine's at the bottom. So I'm going to arrow up to get to the bottom. So arrow up to lin-reg t test, not interval, test. It's a hypothesis test. Lin-reg t test, we're testing it. Hit enter. And x's are in list 1, y's are in list 2. Frequency 1, you only have one of each of them. Now, everybody look up and pay attention. I'm only going to say this once, well, maybe twice. This part here, for all of chapter 10, all of our H1s are going to be not equal to. We don't care if it's greater than or less than. We don't care if it's a positive correlation or a negative correlation. We only care that it's correlated in either direction, either positively or negatively. We don't care whether it's left or right. So it's always going to be not equal to here. So for what we're doing in this class, we only care if it's correlated. We don't care whether it's positive or negative, so we're going to do the not equal to. Not equal to 0. And then leave this one blank, the reg EQ, leave that blank, frequency 1, and then just go down to calculate. And it's going to give it to you. So here it gives you a bunch of stuff that's kind of useful. We'll talk about that later, y equals a plus bx and some other things. Here's if you want to do a p-value way, here's the p-value, right? E negative 4, that's pretty small. It's very small. Here's a and b, which we'll look at later, and r squared. But here's the one we're looking for, our r, 0.98. If you round, 0.982, right there. So you do not have to use the formula. So this formula I tortured you guys to do. I wanted you guys to appreciate it. And I have in the past forced my classes to use that before. But nowadays, I just let you guys use the calculator and stat test lin-reg t-test. So write that down if you need it. Actually, it's at the very bottom of your page. The very, very bottom of the page, it's written there. Stat test lin-reg t-test. And again, you're going to do stat edit, put your things into your lists, and then stat over to test, arrow up to get to the bottom, lin-reg t-test. Right there, lin-reg t-test. And then x's are list 1, y's list 2, frequency 1, leave that alone just as 1, and then pick not equal to. Leave that one blank and calculate. Okay, So you guys turn the page and you have a,
Yeah.
yes, go ahead, Jay.
What does lim rig
I have no idea. No clue. I have no clue whatsoever. All I know is you should leave it blank. All right.
Okay.
All right, so then you guys need to do this problem on your next page. Flip the page, and you will go to, this problem here. Right, yep, this problem here. So lab problem 3 on the next page, just find your correlation coefficient for this one. So again, list 1, list 2, and then do that Lin-Reg t-test. Stat test, Lin-Reg t-test right there. All right, so I'll leave this up here in case you guys don't have your notes.